Hello everyone. In this session, we are going to discuss about types of thermal process. There are different types of thermal process. They are isothermal, adiabatic, isobaric, isochoric, reversible, irreversible and cyclic process. Let us discuss one by one. Before that, what is a thermodynamic process? It is a physical or chemical process that takes place in a thermodynamic system which changes the system from an initial state to a final state. So that is called as a thermodynamics process. The first one is isothermal process. The process in which temperature of the system remains constant is called as isothermal process. So the gas obeys Boyle's law. In order to keep the temperature of the system constant, heat should be transferred out of the system or into the system. So based on this, it is further classified into two types, exothermic process and endothermic process. In exothermic process, evolved excess heat is given out of the system instantaneously. But in endothermic process, the heat is absorbed by the system from its surroundings. So in both the cases, the temperature should maintain constant. The curve showing the relation between pressure and volume of a given mass of gas when the temperature is constant, and this curve is called as isothermal curve. In the diagram, we can see that the pressure versus volume graph, where as the pressure increases, volume decreases, and this curve is called as isothermal curve, and this process takes place at constant temperature. The T is equal to constant. Next one is a adiabatic process. An adiabatic process is a thermodynamic process in which there is no exchange of heat between the system and surrounding takes place. So we can represent it as delta Q is equal to 0. Q is nothing but the heat. So in adiabatic process, there will be no exchange of heat between the system and the surrounding. It means the energy of the system remains unchanged with time. For example, the water inside the thermosteel bottle that remains hot, and this is one of the best real life example for the adiabatic process. And the graph between PV and V for an adiabatic process of an ideal gas is decreasing curve, indicating that as the volume increases, the product of PV decreases. The next one is isobaric process. Isobaric process is a thermodynamic process in which the pressure of the system remains constant. The word isobaric comes from the Greek words iso, which means equal, and baros means a pressure. So here the pressure remains constant. We can take the example of boiling water. When a water boils in an open container, that atmospheric pressure remains constant. So the process is isobaric. Or we can also consider a gas either expands or contracts to maintain constant pressure. This process can result in work being done on or by the system. The PV diagram for isobaric process is a horizontal straight line, and this horizontal straight line representing constant pressure and which is parallel to volume axis. We have pressure versus volume graph here, where the volume is taken along x axis and pressure along y axis. So the horizontal line represents that as the volume changes, the pressure remains constant. So this process is called as isobaric process, and the curve is represented by, or the line is represented by, a horizontal line which is parallel to the volume axis. The next one is isochoric process. An isochoric process is a thermodynamic process where the volume of the closed system remains constant, and it is also known as constant volume process, isovolumetric process or isometric process. One common example of an isochoric process is the heating of a gas inside a rigid container. Since the container's volume does not change, any heat added to the gas results in an increase in pressure or temperature but not in the volume. So the volume remains constant means it is called as isochoric process. In an isochoric process, the work done is 0. Because as the volume of the system remains constant, this means that the change in volume delta V is equal to 0. And as a result, the work done equals to 0. On a pressure volume diagram, isochoric process appears as a straight line which is a vertical line parallel to the y axis which represents pressure. And in this graph we can see that the volume remains constant as the pressure varies. So when the volume remains constant, and that process is called as isochoric process. The next one is reversible process. A thermodynamic process which is said to be reversible is a process that can be turned back to such that both the system and the surrounding returning to their original state with no other change anywhere else in the path or the universe. We can take the example of water cycle. Water evaporates into water vapor, then condenses back into water. And we can also consider an example of melting and freezing of ice. Water freezes into ice, then melts back into water when it is heated. Or we can also consider a slow expansion or compression of a gases. Gases can expand or compress slowly without changing their temperature or pressure. So this comes under reversible process. A reversible process is depicted by a smooth curve on the PV diagram, signifying that the change in pressure and volume occur gradually and in equilibrium. And in the path from A to B, we can see that the process takes place from A to B as well as the process takes place from B to A. So this indicates a reversible process. The next one is irreversible process. An irreversible process in thermodynamics is a process that cannot be reversed and dissipates its energy. And this process occurs spontaneously and which is only in one direction. Example, we can consider a chemical reaction. We know that in chemical reaction, reactants convert into products and the products cannot convert back into reactants, which is irreversible. In electric current flows through a conductor with resistance, which can be a irreversible process. To represent irreversible process in PV or any diagram, we use hazy lines. So in the diagram, we can see that irreversible process can take place in only one direction. It cannot be a reversible. The next one is a cyclic process. A cyclic process in thermodynamics is a series of thermodynamic changes that return a system to its initial state. In a cyclic process, the system absorbs and releases heat, expands and compresses and performs work. So we can take the example of Carnot cycle, cyclic heat engine with the highest possible efficiency, Otto cycle, a cyclic heat engine with 2 isochoric and 2 adiabatic steps, and the network involved in a cyclic process is the area which is enclosed in PV diagram. If the cycle goes clockwise, the system does work. If the cycle goes anti-clockwise, then the work is done on the system in every cycle. Thank you.